Okay, today's lesson is still on derivatives, but it's going to be on the product rule versus the quotient rule. Remember, the product rule is when we have y equals two functions being multiplied together, u times v. We cannot just take the derivative of those separately and multiply them. What we need to do to those is we actually need to take the derivative of u prime times v, and add that to u times the derivative of v prime. That's our product rule. For the quotient rule, the division of two functions, we're normally going to see this as a fraction. It's going to be a very similar start. So y prime is going to be u prime times v. This time it's going to be minus u times v prime all over v squared. We can put those in the correct order. After finding our derivatives, we'll have the correct derivative. So some examples down below. First one is definitely the product rule. I can see that because I have multiplication of two functions. Call this u, we'll call this v. So all we're going to do is just identify them by putting that off to the side. 3x squared plus 2x plus 1, and v is 1 over x plus 1. Now to find u prime and v. Now we're going to take the power rule of each term. So that's just bringing the exponent down and subtracting 1 from that exponent. So this is going to become 6x to the first. This is going to become 2x to the 0, remembering that a 1 came down and multiplied times a 2, and the derivative of any constant is 0. Now to clean this up, 6x to the first is just 6x. 2x to the 0 is really 2 times 1, or just 2. v prime, we do have to do some prep work here. Since I see I have an exponent in the denominator of a fraction, I want to keep that coefficient the same, 1. But now I want to keep the x as a negative 1, since that was a 1 in the denominator. I'm going to keep that 1 the same because I still haven't taken the derivative yet. Now I can move that negative 1 to the front, subtract 1 to make a negative 2, take the derivative of a 1 to get a 0, because the derivative of any constant is 0. Let's just rearrange this really quickly, remembering that negative 1 is our coefficient, and that x squared is going to go in the denominator because it was a negative exponent, and we have to remember that relationship between negative exponents and denominators. So now it's just a matter of putting this all in the correct order to have our derivative function. So f prime is just going to be, let's see, we have to remember to do u prime times v, and then u times v prime, and just add those products together. So a quick fast forward, if we put that in the correct order, this would be our answer. Just check the u prime to v plus the u to the v prime. Now the next is going to be our quotient rule. So I want to make a quick annotation to make sure that I understand that this is u and this is v. And down below, I'm going to just quickly take the derivative of u and v to get u prime and v prime. So u is going to be 2 radical x to the third. V is going to be 2x plus 1. U prime, before I can take that derivative, I need to rewrite my radical function, or my radical. So if I remember, this has an invisible 2 out front. So this is all going to become 2. Keep the x as the base, and remember that the inside goes as the numerator, and the outside goes as the denominator. Now I can take that derivative by bringing that 3 halves out front. So think about that as 3 over 2 times 2 over 1 x, and if I subtract 1 whole to finish my power rule, I'll get 1/2. Okay, now I'm just going to clean this up very quickly. And all I'm going to do is multiply 3 times 2 to get 6, and divide by 2 to get 3. X to the 1/2. I should remember that a fraction is going to be a radical. Just like I turn a radical into a fraction, I'm going to turn my fraction back into a radical. The 1 goes inside with the x. The 2 goes on the outside as the root, and that would be my derivative. For v, all I have to do is take that 1, bring it out front. That's going to be a 2x to the 0. A derivative of a constant is going to be 0. Remember that x to the 0 is really just 2 times 1, so just 2. So that's my entire derivative of that function. Now when I put this all together using the quotient rule, I have to be careful to use the correct order. U prime to v, u to v prime, and don't forget to square v. I'll show you in a moment what that looks like. So after I put it all together, this is my final derivative function. Notice how I have u prime to v and then I have u to v prime, and then I have v squared. If we put that in the correct order, we'll have our derivative. Now, moving on to the very last problem. The last problem is a little bit more complicated because it's 2 steps. We have to find the slope at a certain point, and we know that we can find that slope at a certain point by finding our derivative. So the very first thing that we should recognize is that we need to find our derivative using the quotient rule. So we're going to set this up with u and v, u prime and v prime. Our u is going to be 4 over x squared plus 2, and our v is going to be just 2x. Moving quickly through this problem, before we can take u prime, we might recognize that we have a number in the denominator, an exponent in the denominator. So that automatically tells me that I should rewrite this with a negative exponent, 4x to the negative second power plus 2. We need that so that we can use our power rule. Now we can bring down to make that a negative 8x, subtract 1 to get a negative 3. Remember that that 2 is going to give us a derivative of 0 since it's a constant. Now from there, just rewriting one more time, remembering the relationship between negative exponents and denominators. So negative 8, let's leave that on top as our coefficient, x to the positive 3 power, and I just put that in the denominator. There's our derivative. The derivative for 2x is much simpler. So we just bring the 2 down front, that's just going to stay at 2. X to the 0, we might remember that x to the 0 is 1, so just 2. Now I'm just going to pause for a second, and we're going to put this all together. So just remember that since it's the quotient rule, we're going from u to v prime, sorry, u prime to v, u to v prime, and then we're subtracting those things, and I have to remember to put a v squared in the denominator. So I'm going to fast forward and show you what this is going to look like. Okay, now I have the entire problem finished. So I've put this all together and think about u prime to v, u to v prime, all over v squared. So this is what we're going to look like. And you can see just really quickly, if I were to annotate this, this would be my u prime, this is my v, this is my u, this is my v prime, and here you can see my v squared. So just putting that in the correct order, remembering that this is a minus because quotient rule is subtracting, whereas product rule is adding. So my next step would just be to plug in a 1. So if I were to plug in a 1 to every single one of these cases, okay, I'm going to get a 1 here, I'm going to see a 1 here, I'm going to see a 1 here, and I'm going to see a 1 down here. So everywhere that there's a blue 1 is where I'd plug in a 1. Now I'm going to kind of skip some steps here because we know that, for instance, negative 8 divided by 1 is just going to be negative 8. And that 2 times 1 is just going to be 2. 4 over 1 squared, or 4 divided by 1, is just 4. And then 2 times 1 is just 2. All right, so I did kind of skip some really quick steps there, just because we're using the number 1. I would not recommend that for any other number. Now I'm going to do my order of operations. You can see here that what you may predict is multiplying these to get 16, negative 16. And this is going to be a 6 times 2. And I'm going to multiply those before I subtract. So what this is going to turn into is negative 16 minus 12 all over 4. We can subtract those negative 16 and that negative 12 to get negative 28 over 4, which turns into negative 7, which is our slope of that entire function at x equals 1.